In this video, we shall learn numerical solution of an ordinary differential equation of first order and first degree by using Euler's method, and one problem of solving an ordinary differential equation of first order and first degree by using Euler's method. Like the video, subscribe to the channel, share this video link with your friends, gain the knowledge and rule the world. Numerical solution of an ordinary differential equation of first order and first degree can be solved by using three methods. One is the Taylor series method, and second one is Euler's method, and the third one is Runge-Kutta method. In this video, we shall see how to find the numerical solution of an ordinary differential equation of first order and first degree by using Euler's method. Euler's method is the simplest method in finding the approximate solution to an first order first degree differential equation written in the form dy by dx is equal to f of x comma y. To solve the above equation, here we will be taking h, which is a very small and it is called as a step length. To approximate the solution, here in Euler's method we will be using two formulas. First one is xn plus 1 is equal to xn plus h, and the second one is yn plus 1 is equal to yn plus h into f of xn comma yn. The values of n, h, xn, yn will be getting from the question itself. Y at 0.3, given that dy by dx is equal to x plus y, with y of 0 is equal to 1 at h is equal to 0.1 by using Euler's method. So solution, given dy by dx is equal to x plus y, that is f of x comma y is equal to x plus y, and they are also given the initial condition, that is y of 0 is equal to 1, that is x naught is equal to 0 and y naught is equal to 1, and they are given the value of h, and that h value is 0.1. We need to find y at 0.3, that means y of 0.3 has to be found out by using the Euler's method. They have given, we need to find a y value at 0.3, and initial value they have given y of 0 is equal to 1, that means the step length is 0.1. Therefore we need to solve this one by repeating the calculation of x and y values 3 times. That means 3 times we need to find the values of x and y. By Euler's formula, we know that xn plus 1 is equal to xn plus h, yn plus 1 is equal to yn plus h into f of xn comma yn. So first we shall find the values of x1 and y1. Consider xn plus 1 is equal to xn plus h. Here we need to find x1 value. So for that purpose we take n is equal to 0 and h value is 0.1. Therefore we can write x0 plus 1 is equal to x0 plus 0.1, and x0 value is a 0 which has been given in the question, and 0 plus 1 is 1. Therefore we can write x1 is equal to x0 is 0 plus 0.1. x1 is equal to 0 plus 0.1. So 0 plus 0.1, upon simplification it will be 0.1. x1 is equal to 0.1. Next we need to find the value of y1. Consider yn plus 1 is equal to yn plus h into f of xn comma yn. Here we need to find the value of y1, therefore we take n equal to 0. So it will be y0 plus 1 equal to y0 plus h value is 0.1 into f of x0 comma y naught, and we know the value of x naught, y naught. X naught is 0 and y naught is 1, which has been given in the question, and 0 plus 1 is equal to 1. Therefore we can write y1 equal to y naught value is 1 plus 0.1 into f of 0 comma 1. And in the question they have given dy by dx is equal to x plus y, that is nothing but f of x comma y is equal to x plus y. Here it is f of 0 comma 1, that can be written as 0 plus 1. Therefore we can write y1 equal to 1 plus 0.1 into within the bracket 0 plus 1, close the bracket. This one in the calculator we can write 1 plus open the bracket 0.1 into open the bracket 0 plus 1, close the bracket, close the bracket. This will give the answer, and that answer is y1 equal to 1.1. That is y of 0.1 is equal to 1.1. So we have calculated the value of y at x is equal to 0.1, and in the question they have given y of 0.3. That means you need to do the repetition of these calculation of x and y again 2 times. Therefore at the second time we get y of 0.2, at the third time we get y of 0.3. So y of 0.1 is equal to 1.1 means y is equal to 1.1 at x is equal to 0.1, and we can write this one, that is x1 is equal to 0.1 and y1 is equal to 1.1, and this one we will be considering for the next step of solving. Euler's formula, we know that xn plus 1 is equal to xn plus h, yn plus 1 is equal to yn plus h into f of xn comma yn. First we shall calculate x2 and y2 since it is the second step. So consider xn plus 1 is equal to xn plus h. Since it is a second iteration, we need to write the value of n as 1 and h we know it is a 0.1. Therefore we can write x1 plus 1 is equal to x1 plus 0.1. Now substitute the value of x1, and 1 plus 1 is 2, that is x2 is equal to 0.1 plus 0.1. Since the x1 value is 0.1, therefore upon simplification x2 is equal to 0.2. Consider yn plus 1 is equal to yn plus h into f of xn comma yn. Here we shall consider the value of n is equal to 1 since we need to find the value of y2. So it will be y1 plus 1 is equal to y1 plus 0.1 into f of x1 comma y1. H value is 0.1. So 1 plus 1 will be 2, and y1 value just we have calculated, and x1 and y1 values just we have calculated. Those values we substitute in place of x1 comma y1. 1 plus 1 is 2. Therefore we can write y2 is equal to y1 value. Y1 value is 1.1 plus h is 0.1 into f of x1 comma y1. F of x1 is 0.1 comma y1 is 1.1. So y2 is equal to 1.1 plus 0.1 into f of 0.1 comma 1.1, and we know f of x comma y is x plus y. So in that form we can write f of 0.1 comma 1.1 as 0.1 plus 1.1. Therefore, we can write y2 is equal to 1.1 plus 0.1 into within the bracket 0.1 plus 1.1, because f of x comma y is x plus y. So x is 0.1 and y is 1.1. Therefore, we are writing within the bracket 0.1 plus 1.1. After that, next, this one in a calculator, we can calculate this one in the form by writing 1.1 plus open the bracket 0.1 into open the bracket 0.1 plus 1.1 close the bracket, and this will give the answer, and that answer is y2 is equal to 1.22. that is y of 0.2 is equal to 1.22. So what is the value of y at x is equal to 0.2? It is 1.22. Y is equal to 1.22 at x is equal to 0.2. That is x2 is equal to 0.2 and y2 is equal to 1.22. x2 is equal to 0.2 and y2 is equal to 1.22. Since we need to find the value of y at x is equal to 0.3, we need to do another one step of finding x3 and y3. By Euler's formula, we know that xn plus 1 is equal to xn plus h, yn plus 1 is equal to yn plus h into f of xn comma yn. Now, since it is a third step, we need to find the value of x3. Therefore, what we do is consider xn plus 1 is equal to xn plus h. Since it is a third step, we write n is equal to 2. Therefore, it will be x2 plus 1 is equal to x2 plus h. H value is 0.1. Therefore, we can write x2 plus 1 is equal to x2 plus 0.1. And we know the value of x2 and substitute that one, and 2 plus 1 is 3. Therefore, it will be x3 is equal to 0.2 plus 0.1. Upon simplification, x3 will be equal to 0.3. Next, we need to find the value of y3. We need to find the value of y3. For that purpose, consider yn plus 1 is equal to yn plus h into f of xn comma yn. Here, since it is a third step, we need to take the value of n as 2. So it will be y2 plus 1 is equal to y2 plus h value is 0.1 into f of x2 comma y2. So we can write y2 plus 1 is equal to y1 plus 0.1 into f of x2 comma y2. So 2 plus 1 is 3. Therefore, it will be y3, and y1 value just y2 value just we have calculated, and that value is 1.22, and h value is 0.1 into f of x2 value is 0.2 and y2 value is 1.22. Therefore, we can write y3 equal to y2 value is 1.22 plus 0.1 into f of 0.2 comma 1.22. F of x comma y is given by x plus y. Therefore, here it is f of 0.2 comma 1.22. This can be written as 0.2 plus 1.22. Therefore, we can write y3 is equal to 1.22 plus open the bracket 0.1 into open the bracket 0.2 plus 1.22 close the bracket twice. In the calculator, you can write this one to calculate in this form 1.22 plus open the bracket 0.1 into open the bracket 0.2 plus 1.22 close the bracket, and this will give the answer, and that answer is y3 is equal to 1.362. y3 is equal to 1.362, that is y of 0.3 is equal to 1.362. In this way we can find the numerical solution to an first order first degree differential equation of the form dy by dx by Euler's method. Like the video, subscribe to the channel, share this video link with your friends, gain the knowledge and rule the world.